And then field operations and superintending, that's really the kind of in-depth field work. But I'd say those second two really go hand in hand once the project is launched. The first one's a little bit more of a introductory area. So like I said, this is pre-construction estimating. I'm with Turner Construction. Just a quick intro. I'll try to get through these quick. I know we have 3 different presenters, but my name is Charles Johansson. Again, I work for Turner Construction. I'm currently a project manager there. I do have a background in architecture. That's kind of where I started out. Spent about 4 years in an architecture office back in San Francisco. Got a lot of good experience there, and then ended up switching over to the kind of construction side of things back in 2018. I still am pursuing my architectural registration, so definitely have a lot of respect and a lot of appreciation for architecture. I think the more all 3 of these ACE disciplines can collaborate early in the process, the better. I think if anything, for those of you looking at programs in school and everything, just keep in mind it's not you don't have to stay on the road that you pick initially. So you can always move around. There's more in common than you would think between all these disciplines. So just keep that in mind when you're making a decision. It's not an end all be all. So again, like I said, we're going to talk about kind of the pre-construction phase. So this is a typical, what we call project delivery, design, bid, build. So typically a client hires an architect, the architect designs the project with input from their consultants. And then once that design is completed, it's packaged up, given to the contractor who bids it, which means goes out and gets pricing from all the various trades, puts that together and gives it to the owner. So the pre-construction phase, I think, is getting stronger and more prevalent, which is good. But it's really kind of early engagement between the architect and contractor to sort of sort through a lot of, coordination issues or cost issues, things like that early in the process. So you're not battling with it while you're trying to build the building at the same time. So like I said, within the project life cycle, here's sort of the pre-construction services. Again, there's varying areas or stages within this that the contractor can be engaged. Sometimes from the very beginning, sometimes it's not until the final design. Just depends on the project and the owner. But in the grand scheme of things, this is kind of how it's broken down. So planning is very early, kind of concept planning. These will be touched on, I'm sure, more when we talk about architecture. Programming and design. So that's when the spaces in a building start taking shape, different functions. That's probably the first place where you'd really see budget pricing, just based on kind of rough area or function of a building. Final design is when you start getting more detailed. So this is when constructability reviews become very prevalent, trying to uncover problems earlier rather than later. And then obviously advertise and award. So this is, like I was saying, kind of the bidding and final pricing exercise of the pre-construction phase. So again, it's kind of the 4 basic, or I'd say main components. So estimating and bidding, obviously cost is a huge driver in projects. Schedule is another thing that Steve will touch on later in the kind of operations field management side. Constructability, obviously, just assessing how well things work together. I'll get into more detail on this one, but really just trying to uncover any potential issues down the road early and often. And then logistics is a really big one, especially working in urban sites, say downtown Denver, space gets tight. So timing and really orchestrating how a project is built is just as important as putting everything together or purchasing things. So we like to kind of touch on all those things. A big slogan for I know my company is plan the work and work the plan. So it's always better to plan on the front end. No matter what, you'll save on the back end in both time and money. So estimating and bidding, what you see here on the top right is a takeoff, what we call it. So it's when you really start quantifying, whether it's, here you can see the different colors are floor finishes, for example. So we want to get a quantity of every material, every system you're putting in a building. And then the more detail you get on those, the more you can start adding, good, reliable costs to them. We'll get into a slide later where it's there's a couple different ways to estimate or budget. And it kind of goes hand in hand with the development of the drawings themselves on the design side. So again, what we're talking about is getting from kind of concept to final building. And you'd be surprised how many times owners will come to us with a napkin sketch and ask, how much is this going to cost? So that's why we have different ways to, work through that. The more you build, the more experience you get from different building types. So that's a lot of, really good information to have on the front end. That's really the way you gain clients, is having the ability to assist on the front end and not have to wait until documents are finally completed. So here I just kind of broke down 3 main budgeting or estimating methods. So starting with kind of the outer rings, so this would be schematic design when things are still sort of being developed. So like I said, historical data, or GSF, which is gross square footage budgeting. So this is, for example, owner wants to build an apartment building. They know they have 20 units. You say, okay, based on, this location and the level of finish you want, let's call it $120,000 a unit. You could break that into square footage as well. And that's kind of where you start establishing baseline budgets. This is usually if an owner needs to go out for funding or something like that. So it doesn't need to be totally detailed, but you do want to have at least a good basis that you're not overshooting or undershooting at this stage in the project. System budgeting. So I'd say this is more in the design development phase. So before we have final, maybe finished selections or final detailing, you can start allocating based on system. When I say system, that is, your main disciplines. So civil, earthwork, finishes, furniture, kind of the main buckets. They can be, divided up later, but that's where you start adding system cost to a project. And then the unit cost method in the middle is kind of the most defined. This is when you have complete documents, things have stopped moving around, all the finishes have been selected, and you can start putting really accurate pricing and quantities to each and every part and piece of a building. So this is kind of an example of that system budgeting method. So as you can see here are kind of our major subsystems on the left. Again, these can be broken down. For example, interior construction can be broken down into partitions, flooring, tile, paint, things like that, more finished trades. Same with some of the others. So this is a project I'm actually working on now. And this is what we were given, in the RFP phase. This is part of the RFP. And they wanted a cost to build out these spaces within the airport. So all we knew is they wanted a kitchen, they wanted a club, and they wanted like a tap room, mezzanine bar. And so we put together a pretty detailed estimate for them just based on one very, very simple drawing. This is it says systems, which should say unit cost method. So this is, as you can tell, we have complete floor plans, we have enlarged floor plans, we have detailed drawings. Then on the left, we can start really putting quantities and costs to each and every wall type, detail types, things like that. So this would be the most finite kind of final budgeting phase of a project. And then bidding and leveling. So this is when, after we do our internal budget and tell the owner, hey, here's how much you should expect to pay, then we're typically obligated to go out to a defined amount of subcontractors to see who can give us the best price and in turn give the owner the best price. So this is where we go out, we solicit bids from several subcontractors in each trade and start, we call it leveling. So you want to make sure everyone has price apples to apples. No one is including something that other people aren't or vice versa. So making sure everyone's on a level playing field. And when you commit one of these numbers at the top to the owner, that's what is going to be paid for the project. That's kind of a promise on your end and the subcontractor's end. So you want to make sure you have everything really well defined and you scrub through proposals and things like that. Scheduling, like I said, I'm sure Steve will go into this more in depth, but this is one of the main responsibilities of a contractor is the project schedule. So a lot of times the owner will say, hey, we want to open our club on, April Fool's Day next year. there's going to be a big premiere event or something like that. So you have a hard date, and that usually will dictate a lot of your trades, a lot of your pricing. If you need to pay people overtime to get done faster, that's kind of what you assess during the pre-construction estimating and bidding phase, so that everybody knows the expectations and they can have an accurate price for that. And then constructability and feasibility. So I think this is a really big one as well. A lot of times contractors we've brought on, even if they're not involved with the project construction, a lot of owners will bring on contractors as a part of their pre-con agreements to just assist in constructability, logistics, things like that. So say an owner has 3 different sites they want to build on. One of them is on top of a humongous hill. They have to do a bunch of earthwork to dig it out. That's where we can kind of get involved with feasibility and say, hey, here's your risks, here's your big ticket items. And maybe the site that's a little bit farther from downtown, but would have, less earthwork and utility work would be a little bit better idea for you. So that's kind of the feasibility, really front end type things. And then on the bottom left here, you can start seeing how we use BIM, building information modeling, 3D modeling, trade coordination to make sure that once all these drawings are published and we go to the field, everything is going to fit, go where it's supposed to go and where it needs to be. There's not going to be conflicts where we have to start moving things around, because that's just, again, a big time and money waste within the project. So that's becoming a lot more relevant. If you like the technology aspect, the software aspect, that's definitely an emerging trend in construction. We're trying to catch up to the design side in that vein. So a lot of companies are starting to, have certain divisions within their company where you can really get into, for my company, we call it virtual design and construction. And it's almost like design, you're still building a model, and then you're just coordinating with other trades. So that is also, really exciting if you like the software side. Constructability, again, we'll look through the drawings, look through the details. Some of these things on the right are a lot of conflicts to look out for. So equipment location, like I said, with that model, you want to make sure there's not a plumbing pipe that's going to be going through a mechanical duct. That can't happen. So that's one thing we look at. Material compatibility. So for example, there's certain metals that don't work well together. So if you have a metal siding, an aluminum siding, there's some metals for nails, for example, that you don't want to use with that because it'll actually corrode the metal, cause rust, things like that. So we look for material compatibility, tolerances and drift, and inspection contraction. That's a big thing, especially on big buildings. People don't really realize how much material can grow and shift and contract with different weather. So this is a really big thing to look out for and a very big risk for envelope, especially. You want to make sure, in the summer when it gets hot, wood's going to expand. In the winter, it's going to contract. So you want to make sure it's not, anything brittle isn't within those materials that could break or crack or anything like that. And then coordination between disciplines. This is an ongoing thing. Obviously, it's very big in design, redlining sets of drawings, making sure everything's coordinated across sets. And this is really just getting another set of eyes. As buildings get more and more complex, it's almost impossible to see every single coordination issue, especially as drawings change so much. So just another way that we can be sort of another set of eyes and hopefully help out on the front end planning effort. This is just one thing to keep in mind. So, as we design and as we build, the curve kind of shifts as far as who influences the project. And as time goes on, it's harder to change design and it's more expensive to change construction. So you really want to target somewhere, where those lines converge to make sure everyone's kind of on the same page and the documents are in a good shape. So you're avoiding, time and money wasting efforts on the back end. Admittedly, a lot of this is typically caused by owners, to be honest. If you pass that kind of typical junction, that's where a lot of the requests come from that will have an impact on time or schedule. But again, the earlier you can attack it, the better it's gonna, the easier it's gonna be on the back end. These are just some funny constructability bloopers. I always like to see these. Obviously, they're very uncommon, kind of ironic too, but Obviously reviewing your RCPs, reviewing your security plans versus your signage plans, right? You don't want to put a sign in front of a camera. It's not going to do anybody any good. The one on the right, I hope, is photoshopped. That would be very, very embarrassing, but you can see how, you'd want to catch that earlier if there's a benchmark off or something like that before it becomes that big of an issue. Then lastly, like I said, site logistics and phasing. So especially in downtown sites, this can get very, very complicated. If you think about, for a building like this, how many semi trucks and trailers are going to pull up to the site, how many cranes you might need, how much material you're going to have to store. It takes up a lot of space outside where you're actually building the building itself. So logistics is huge for us. I did a project in San Francisco where we only had 4 parking spaces on the side of a road for delivery space. So that means 1 truck, one day. You really need to be smart about sequencing deliveries, making sure material is getting to the site only when it needs to. And then, cranes, other things like that, they need to be engineered. Safety comes into play. So the more you can kind of get ahead of this, it'll really, really help on the back end. You do not want to scramble to figure out, if you have 2 semis coming at once and one of them can't park, that guy might leave and not come back for another week. So that's a huge thing to keep in mind. It's something that I think is often overlooked when it comes to the construction of a building. Just kind of a further example of that, comes down to planning work. So, you may have utility lines, you may have structural systems below ground, and then you may also have a crane pad. When do you put the crane in? When do you run the utilities? What's the most cost effective and efficient way to do things like that? That's another thing that we'll start to look at and is starting to be leveraged by those BIM tools connected to schedule, making sure everything's going to run flawlessly once you actually hit the job site. And then this is kind of a more developed schematic of that. So, again, this is tied to our schedule. It kind of runs through a couple different pieces of the construction, where your dump truck's going to pull up, where your concrete truck's going to pull up, where your pump truck's going to be going. And then you can see it kind of progress through the project, crane location, structural erection. Then once you start getting into envelope, where's your scaffolding going to go? And then to kind of final construction of the building. Obviously basic, but it is a powerful tool, especially for owners and designers alike, really, to really see kind of the progress, to see how things are, the plan, right? You want to see how it's supposed to go. And then it tries to, can keep us honest too, make sure we're doing it exactly like we said we're going to. So I think with that, that's really pre-construction. I know I sort of glossed through it, so obviously feel free to ask any questions that you need. But now I guess we'll move into sort of the pure building aspect of construction. So thank you.
All right, give me a sec. So I'll be talking more on the project engineering and management side of things. I guess I didn't put a slide in here for background, I should have, but my background has been, I graduated from the Colorado School of Mines in 2015 with a degree in civil engineering. I did a few design internships and decided that I wanted to go the construction route instead. And so I went straight into a construction job straight out of college. I worked in Texas, building bridges as a structures field engineer. And then I moved back to Colorado, where I did a pump station near Greeley, Colorado. And then finally, in 2017, I took a job with a company I'm with now, GE Johnson Construction, and I work for our earthworks division. But I do have vertical experience here as well. For a year, I was out on a middle school project. So just the basic goals for every project once the construction is slated to start. So the most important goals are everybody goes home safely. That should always be everybody's goal number one. You want everybody to get home safe and sound to their families, not ever have to worry about getting hurt. We want the project to finish on or before schedule, finish on or under budget. And then really important is that the owner is satisfied with the end product. So just a quick overview. So the project engineer portion is going to be a lot shorter because as a project engineer, you kind of you dive into a lot more than just this aspect of things, but this kind of hits the basics. And then project management will go into like owner relationships, contract negotiations, risk management, budgets, and then just communication, one of the most important tools of being in the construction world. So as a project engineer, when you first get out of college and you decide to take this route, going to construction, you'll most likely be put into a role like this. Really, to put it bluntly, you're really a grunt on the project. You learn so much in such a short amount of time. You're expected to deal with submittals. So examples of submittals are shop drawings. And so as far as like the MEP trades and stuff go like that, once that is designed and a subcontractor is chosen, they usually have to provide their own shop drawing showing exactly what is going on in the system and that they are ordering all of the correct material and putting that all in. And so as a project engineer, one of your main responsibilities is to review these shop drawings and making sure that they're matching the contract drawing exactly. Any product data, and so usually along with drawings, one thing that should be noted is that you get a giant book of a contract project specifications that are given to you by the architects. And so this usually lines out the exact materials that you need, the means and methods to installing some of them, how insulated stuff needs to be and just things like that. And so we'll receive product data from the subcontractors or suppliers, and it has to match exactly to the specifications. Oftentimes we'll get requests for substitutions from certain subcontractors if they think that a material might be better used for the project depending on the location, because sometimes you'll get designers that will design the project and they don't actually live in the state where they're doing the design, and so they kind of miss on what is more appropriate for the project. I know we've had some with zoos where they use these designers that do zoos all over the world, but they didn't look into the climate of Colorado, and we had to change quite a few things as the project went on. Last example of submittals that really kind of encompasses everything is the samples. You're going to coordinate these with the architect to ensure that they're getting the correct look that they want. So we'll get samples of, window finishes, carpets, tiles, you name it, anything that has any kind of color or finish, paint. We're going to get samples of those, and so that the architects can coordinate with the owner to make sure that they're getting the desired look that they want. Second part of being a project engineer, procurement is just trying to make sure that we're getting all the materials onto the job site at the correct time. So you have to know all of the lead times for any projects. How long is it going to take to get ordered, shipped? You have to take into account the submittal process, because usually once you submit something to the architect, it usually takes a couple weeks. That's usually the standard contract is 2 weeks to get a submittal back. And so you have to build that in your timing. And some items are, multiple month lead times if it's like bleachers or something along those lines, something more complicated, stage materials and things like that. Equipment, what equipment is needed to build the job correctly, and how much is it? And so whether this be the cranes or, for my example, earthworks equipment, making sure that we have the proper equipment called out, and that our superintendents and everybody, we're all on the right page of what is needed to build a job in the most efficient way and the cheapest way if possible, so that we are saving the owner money at the end of the day. And then just purchase orders. These are typically for bulkier orders. You as a project engineer, you do a lot of random one-off ordering, extra stuff that the owner wants, extra materials or whatever they may need, but typically purchase orders are for the more bulky type of large quantities. And quality control. So one of the funnest parts about being a project engineer is when you're put on a job site and you get to walk the job every day, kind of see everything start from the ground up. You get to see when the dirt is first made flat, when the concrete first goes in, and then just seeing every step along the way, the structure going up, the building being wrapped, everything being installed inside. And during that entire process, you should be looking to make sure everything is built, completely to the highest standards of quality, and just kind of preaching that from the start. One great thing about this industry is that, there are so many guys in it that take so much pride in their work. And so, if you can get that going from the start, it just makes, your life a lot easier. Everyone's happy because they're not having to go back and do their work, because nothing costs more than having to redo work. And it's just making sure that the owner has zero complaints with the end product. Usually you do massive quality control walks with the owner. Towards the end of the job, we call it punch list walk, and they'll look through everything. If they see a single mark on the wall, you're taking blue tape and marking it, and taking the subcontractor there later and making sure that it's done completely. And then just what's really important with quality control is coordinating with the trades and just setting realistic expectations, because oftentimes if you don't plan it correctly, say one of the last things to go in any job is typically paint. But if you try to do paint first, then somebody can go in there with a piece of equipment trying to install something, and they're knocking into the finished product, and the guy's having to go and repaint. And so just avoiding stuff like that, because it's usually very obvious. It looks obvious to the owner when they can go in and see. But so the project engineer, that's the small look at it. I know that anybody who's ever been a project engineer can tell you that they do a lot more than that, because there's not a single project engineer out there that doesn't want to become a project manager as soon as possible. And so everyone's just trying to make their way to the ladder, learn as much as they can on the way there. So project management. So I'll start off with owner relationships. I believe this is one of the most important parts of being a project manager, is that when you're put on that project, you're kind of the face of your company. And so you want to make sure that you're putting your best foot forward. And, there's a famous saying, happy wife, happy life. Well, in the construction world, it's happy owner, happy life. You keep them happy, they'll keep you happy. It's just being honest and cordial with them, setting realistic expectations with them, and just really going above and beyond to always ensure that they're happy. Because oftentimes, the last thing you want is a choppy owner or a choppy relationship with the owner. Because if you have a good relationship with the owner, then that leads to future work and future opportunities that may not be given out to other contractors. They may just straight ask you to do the work rather than even sending it out for the typical bidding process. So the second part would be contract negotiations, risk management, building contracts that work for both you and the owner. And then on top of that, subcontracts. Oftentimes, nobody really wants to have any liability fall on their shoulders if something was to happen. And so, it kind of goes back to insurance type of deals, but just building contracts that keep the owner and you protected, as well as making sure that it is fair to the subcontractor so that they know what they're walking into. They know exactly what their scope of work might be on a project, and that there are no missing gaps. So that when you are actually within starting the job or in the job, that you're not getting to a point in time where you realize something was never covered, and you're going to have to go to the owner with your tail between your legs to tell them that something was missed. There are multiple types of contracts that we work with. So GMP is guaranteed max price. It's becoming a popular model with a lot of owners now. And so what it is during the estimating phase, they come up with a guaranteed max price, and they say, we will not go over this. And if we do have any savings, it comes back to you. And so the owners love that, because they get to see the savings directly themselves, or, as it's sitting there, they'll try to spend it, try to get every dollar spent that's already been budgeted to make the project better at the end of the day. Lump sum. So this is typically more for subcontractors than a general contractor. But lump sum is like, hey, here's your scope of work. If you do better than what you're contracted for, then you get to save money. But if for some reason your production slows down, then you're losing money, because it's not exactly fair to the owner to have to pay if production wasn't as fast as you bid it out to be. And the cost plus is everything is tracked, everything has to have backup. And so if a subcontractor wants to bid out $40,000, they have to show $40,000 exactly in labor, materials, and everything that goes along with it, and then their fees, because everybody has to make profit. And so as long as that stuff is all lined out in the initial contract, those work out well because the owner knows exactly what they're getting every step of the way. Budget management, just managing the budget daily. You want to know where every single dollar lies in the project, whether your project is, $100,000 or $500 million. You want to know where every single dollar is. Typically, if you're in the general contractor world, most of that money goes to subcontractors. And so in the lump sum example, like I said earlier, you should know how much every single subcontract is, how much everything is worth, and just really trying to get the most out of every dollar. But on top of that, every single contract has, it's something we call contingency and built in, which is usually a kind of a safety fund for the job. And so that can be either used if like there was weather delays or just if something went wrong, it's like, hey, this was already built in. You guys aren't going to get charged any extra. We got you. But in other examples, like that can be used to add stuff to the job. Say you're getting towards the end of the job and there's this nice contingency fund lane, you can go present it to the owner and say, hey, you guys have this much left over, anything else you want to add in here before we're out of here for good. So you manage the budget daily, but really the maintenance comes monthly through the form of just kind of moving money around in places like, your dollars are always going to stay the same at the end of the day, but if you're doing really well in one spot, you start to kind of forecast it out and see that, hey, we can save money over here, but hey, this trade over here or this part of the building is not doing so hot. So it's just kind of taking a look at that too and saying, we're going to gain money here, we're going to lose money here, so let's move the money around so that we're not having to worry about it down the line. And then finally, communication. I cannot stress how important communication is between every facet of a job team. And that includes, between the owner, the architect, the contractors, the subcontractors, the guys actually doing the building themselves. Everybody should know their responsibilities and everybody should know what needs to be done to constantly maintain a job. As a project manager, you're likely going to have a nice team surrounding you on a project, and they're going to be looking up to you, and you want to be constantly teaching those guys. Whether or not they want to become a project manager, whether or not they want to become a superintendent, you always want to be looking out for opportunities to make people better, make the people around you better. Just constantly teaching communication. And then finally, coordination between all trades on a job site. I've been on what I would consider a small job in my world, a middle school last year, and I had 27 subcontractors on the job at one time, and you're talking hundreds of guys that are working all over the project at one time, and you need to know where every single trade is, and they need to know where each other are. And so there's constant meetings between all the different foremen on the job sites, just so everybody's aware of what is going on a certain day so that nobody's bumping heads or getting in each other's ways, and it just makes everything flow better. So I didn't have really any fancy charts or anything like that. Mine was just more of a talking point, but these are kind of projects that my company has worked on in the past 3 years that I have been directly involved with. And so we have the U.S. Olympic and Paralympic Museum in Colorado Springs, Colorado. This was, like Charles mentioned earlier, one of those jobs that somebody put a drawing onto a napkin for this museum, and it was built like the first designs were based off of those napkin drawings. And so those are all, they call them diamond plates. Every single one of the plates that accompanies this envelope is unique. And so that took a ton of coordination on the project team side to make sure that every single piece was labeled correctly and the guys that were installing knew where every piece was going. Top right, we have a project that's currently happening on top of Pikes Peak. They're building a brand new summit complex up there. My team is directly involved in like the earthwork side of it. And so when you're building a project that's, one of the highest that the world has ever seen, There's a ton of logistics that go into that, just getting material up there, getting equipment up there that doesn't break down. There was a time like a month and a half ago where the wind was so bad up there that it broke all the windows on our equipment. So you just kind of have to prepare, always have your resources ready to kind of tackle those obstacles, which, you know, it does make a lot of fun. The world of construction is never, ever boring. Bottom left, we have Rockmont Hall. This was at Colorado Christian University, I believe, in Lakewood. Just another dorm hall. We've done quite a few projects for Colorado Christian, and they're fantastic clients. They're so easy to get along with. They have some of the coolest ideas that get brought to the table, and our guys, you know, really enjoy being there. And then the bottom right is Children's Hospital, St. Francis Medical Center in Colorado Springs, Colorado, which was a huge add-on, so they can get, you know, the Children's Hospital into Springs, because, you know, at the time there was only the one in Denver, and so the families from Southern Colorado were having a hard time, you know, being able to, if their kid was there, or if a family member had to work, of commuting. But this gave them the opportunity to stay home, and, you know, if they had to go to work, one parent had to go to work to make sure everything was maintained, that they still have the chance to go see their kid every night. And then I have a short little video to kind of show what goes on a project and kind of the coordination required. So this is in Colorado Springs. It's the Colorado Springs Switchbacks. It's a soccer team. They're building the new stadium. So this is just a quick time lapse, but it kind of gives you an idea of all the different trades going on at one time. You have the earthworks going on over here. They're doing all this shoring to make sure that the concrete is up here correctly. But all of this happens every day, and I can guarantee you there's a project manager and a superintendent that are aware of every single tiny detail of what is going on in this project, and just the obstacles they have to overcome. So that's all I got. I will pass it on to Steve.
Share the screen. All right. Good afternoon, guys. My name is Steve Sipkovich. I am a superintendent also with Turner Construction. I've been with Turner for 5 years now. And if you're like me, when I got to Turner, I said, what the hell is a superintendent? I don't know what this job title is. I don't know what they do. What is it? So the superintendent is really on site the builder, the kind of the person who is in charge of truly the building, right? So you have the project manager who's in charge of the paperwork side, the money side, the getting the subcontracts in order, kind of the face to the owners. The superintendent is the person who's the face to all the trades, all the different companies working on a job site. Superintendents, you have a superintendent on every single project, right? Just like you have a project manager on every single type of project. And I thought to myself, the superintendent not only builds jobs and builds, manages job sites, but also builds teams within those projects. So we'll take a look into this a little deeper in the next slide. Kind of the three pillars, right, are of a superintendent's responsibility are schedule, quality, and safety. And you see safety right on the top of that triangle, by far and away the most important out of any of these. So let's look at kind of the different teams that make up each of these groups of people on a job site, right? For safety, your client's obviously involved in that, right? They don't want anyone getting hurt on the job sites and want to make trade partners, the individual workers who need to be safety people, both from the general contractor and various other trades. They're going to show up and deliver something. Do they understand the safety culture on the job site? Do they have the appropriate protective equipment when they show up? Do they have what they need? In scheduling, right, it kind of almost trickles down like this, right? When you look at how a project schedule develops, you have a client that says, hey, I need a new building, or I need a new house, whatever. And they say, this this building, we need to move in at X date, right? Or we have to have this operating room open at this date, or there's a big concert happening on this date. The stadium's got to be done, right? Design team comes up with a design, some input, ideally from the GC, and kind of come up with the design and with this construction schedule that work together to meet the client's needs. The GC then looks to the various trade partners, different companies actually doing the work, and says, okay, this is the allotted time that we have. How do we make this work, right? The trades, the actual subcontractors, the people that are experts in these fields, they know what it takes to do their work, right? They're the ones we really want to talk to when determining how to sequence a project, how to break areas up, how to get things done in a way that supports the design and the client's schedule. And finally, as Daniel alluded to in the previous presentation, the general contractors project management team is critical of this as well. They're the ones looking out and saying, okay, we need to be done by this date, right? We probably need to have these companies under contract by these dates so we can get going right away. We need to make sure we have some of the really important long lead time items, like maybe air handling units, things that go on a building's roof, maybe the structural steel, if it's a steel frame building. These things need to be released quickly so that you have them on your job site when they're due. And then finally, quality. This is a huge thing. As both Daniel and Charles mentioned, no one wants to come back to a job once you're done and out. The client doesn't want you there because that means something's broken, right? The design team doesn't want to be there because that means something's wrong and they're going to have to find a fix, right? So all these different people are involved in quality. The design team is going to come up with the design that works. The trade partner is going to do it the right way. In a lot of cases, for specialty items like roofs or mechanical equipment, manufacturers will even send out representatives to come and make sure that whatever their product is installed correctly and that it's functioning properly before it's turned over. And finally, you have city, state, and federal inspectors. So cities always have their own building departments, right? Whenever you're going to build something, you have probably 5 or 6 different city inspectors that come through and look at different parts of the project on a continuing basis. Some projects like healthcare or schools and nursing home facilities, the state of Colorado actually gets involved and does inspections on a lot of the same things the cities will look at. And finally, federal inspectors for maybe some more specialty projects like federal highways or maybe big energy projects. You might even have federal inspectors out. We're going to take a closer look in the next few slides at the logistics of a project and the scheduling or the sequencing of work. We're going to use this building as an example. This is Denver Health's new outpatient medical center that just opened at the beginning of this month. It was a project I've been on for 2 years now and finally saw first patient. Started like this, right? So there's an old administration building here. There's a parking lot. How do we turn this? Starts with logistics of a project, right? So we'll look at, okay, this is a really pared down plan for how we're going to access the project, how we're going to set up our enclosures, people safe in the vicinity, right? You'll see our temporary fence set up all the way around the job site. We have some parking spaces that are blocked off on top of that parking garage you saw in the previous photo to keep cars and people safe when this building here is being torn down. We've got our offices and site gates. You can see the fire hydrants are highlighted here as well. And this is what that looks like. I've noted a couple things on here, right? And just like the offices, some storage laydown areas. Our site fence extends all the way around. We've got a road closure. And up here on the parking garage, you can see a lot of the area to keep people safe, right? And then some protection for the existing building. This gets significantly more complicated as you get farther along in the process. In this photo, there might only be 2 or 3. You get to something like actual erection, same job site. You see the same parking garage here, the job site trailers in the same location for south part of the building and the north part of the building with the road running through them. This orange line here is indicating how loads of steel are going to access the job site. You see that there's a tower crane, and the tower crane's pick radius is noted here. And a note to safety, right? We have on here the capacity of that tower crane all the way out at the very tippy tip of its jib. You see the parking lanes, we've got those closed off. Those are part of the job site at this stage. You see little things like dumpsters and temporary toilets, things that are important to the workers on the site every day, right? There's also nods to the owner on here. How is the general public and the owner getting from this parking garage where all the doctors and nurses park over to here, which is the main building, right? That's a hugely important consideration for the 200 or 300 people that park here every day and need to go and save lives over here. So here's how that all looks, right? There's our site fence again. We've got some overhead protection for people waiting at the bus stop. We've got our delivery lane right here for steel trucks. I've got porta-johns, site fence, job site offices. This is a little blue dumpster here. Some additional laydown space, right, for miscellaneous equipment and materials that have arrived early, and a dedicated laydown area for steel as that comes and is staged to go up and get hung in place. So this is kind of a brief general look at how to think when you're setting up a job site, right? How do I get workers where they need to go? How do I keep public safe? How do I keep my owner happy by making sure their special considerations are taken care of? We're going to switch gears now and use this same photo to look at, or to begin looking at, scheduling. So in this photo, there are 4 or 5 pretty good size operations going on. This guy down here is a concrete pumper. It's pumping concrete into the basement. We're doing, I believe, a slab on grade pour in there. Underground electrical and mechanical systems are going in underneath here. There's erection happening here. Right? This area is all built out already. We're going up to this level on the north part of the building. And then the south part of the building here, they're decking. So this gets into really the sequencing. How can we get multiple activities to happen at the same time and do so safely? You'll notice there's no steel erection happening. It looks like it's kind of snowy or wet, so there's no iron workers there, which means it's safe to have concrete pumper down here and the concrete crews running around. There's 2 levels of decking installed here, which means we're safe to go ahead with our underground activities on the first floor of the building. So you see, when you really look at and think through how a project's going to be built, there's never time to do one activity, then another. These things have to overlap, but they have to do so safely and in a way that supports the client's vision, the architect's vision for the project, and in a way that ensures everyone the adequate time and space to do their work in a quality way. We do all this with a schedule. So this is a short schedule put together a couple of weeks ago for a job we're looking. I don't necessarily want you to look at all the little details, but I want to look at more specific how the different kind of chunks of this schedule work together. Right, so up at the beginning, the project manager, the project engineer, crazy, soliciting bids from trades. We're trades under contract. We're getting cost after we've got all of our ducks in a row from talking to the various trades, right? We have long lead time items, curtain walls like glass, right? Structural steel, door frames, mechanical equipment. So all these things, these at the end dates of these, you'll see is where they actually need to be present on the site to go get installed the very next day. These are pretty decent lead times for those items. These are working days. So 70 working days, that's like 2.5 months. If you need that on your job site tomorrow and these guys aren't under contract and don't have approved signs, we're in trouble, right? That's a pretty good size hit to the schedule. So these are truly the dates that we need to make sure those vendors have contracts, they've got approved drawings, their designs are good, and they can go start making whatever it is that they're making. Farther down, we get into mobilizing and actually starting to do the work, right? So we mobilize the site, maybe we'll put up our site fence and maybe make some access roads, whatever's necessary for that particular job. Then we start with the subground foundations, right? So we're doing everything below the ground so we can then come up and build on top of it. Once we get to that point, we're moving into the structure, right? We're getting above ground. We're starting to go vertical, which is a huge milestone on any project. Underground's it's a scary place. You never know what you're going to find down there. Once we've got our structure up, our building can start bearing weight. We'll go and wrap it, right? We'll cover it with an exterior wall, whatever that might be. Maybe it's brick, maybe it's metal panels, maybe it's, whatever. Maybe it's a lot of glass, and we go and throw a roof on top. So once we're at this point, the building's quote unquote dried in. That means that we're good to start actually doing work on the inside. We don't have to worry about water or extremely cold temperatures, wind, destroying things that need to stay decently conditioned and dry. Just seeing here, we start typically projects with the high overhead electrical and ductwork and things that are going to be hard to get to later with a bunch of things on the ground like walls or furniture. So you see all this overhead work. And once you get the overhead work generally completed, we'll start framing walls. You see layout and frame walls. What you'll see in this schedule is the building, this proposed building has been broken up into 3 phases. So you'll see on the first page here, the west wing. Next page, the lobby and public waiting area. So we're kind of moving through the project. We're creating a flow from west, center, and then east. So we're creating a pathway for our trades to move. 400 people on a job site all at once because no one can move around anywhere because there's a ton of other people there, there's a ton of other material there, right? And you work to create a flow to kind of break the building up into chunks. So you'll see this same flow west, center, east repeated through the rest of the project. So at this point here in the schedule, we've got our walls up, everything up above the ceiling is taken care of. And it's time to start closing the walls, putting drywall and insulation in. Right, so you'll see again, west, center at the lobby and public waiting. And then on the next page, you'll see the east. So we generally build, we'll put drywall on the walls, right? Mud them or spackle them, depending on where you're from, say a little differently. Do some paint, doors, ceiling grid, and then we work on the floors. You almost work the high down. Last little bit of it. Once we've got the walls all painted, the ceiling tiles all in, everyone's happy, we'll go and do a clean, deliver furniture, building, so deliver medical equipment, and wrap up the. At this point, the owners and architects come and they do what's called a punch list walk of the building, and they'll kind of tell you all the little things you missed or everything that isn't quite right. And so you go through and adjust it, and then the owner comes in and you're out. Everyone's ideally happy. This here is our project, right? So I took the general idea for how this site could be laid out. Community center up here on the north side, and then houses on the south end of the site, and then some sort of how would I go about building this if this project were handed to me? So all right, first we get our site fence down, right? We got our job site trailers and porta-johns, dumpsters established. Maybe we need to do some temporary protection for people at the bus stop. If this building's 2 stories tall, you probably want to make sure people in this area are protected as they're going by the job site. When we actually look at building this, right? So how do we make sure that this all finishes on time? Well, we're probably not going to be able to just do one thing and then the second thing and then the third thing. We need to be able to work on multiple areas at once, right? So this community center is probably the most intense part of this project, right? It's the biggest structure for sure. And it has the most requirements in terms of interior systems like mechanical and electrical, things like that. So I figured, okay, we started the community center and we're probably okay to start in this housing area down here at once, or both of these at the same time, excuse me. So I kind of said, all right, while this is going on, we'll start here as well and work this way with our kind of housing pads and all that. And what that generally looks like. So I've got that here, right? These two move to these areas and finally finish up. We walk through the site, we go, all right, we're going to set up, right? This is kind of the preparation phase. How do we get to actually building? Excuse me. Once we've got our site established, right? Do that for the whole thing, get our access road set, and then we break off into building. So we've got our community center and our housing group, the first housing group one, the first chunk of houses that we're going to go and set up. As this community center is being built, we'll work our way through the sequence here and finally finish up with the site improvements in the outdoor community area, do the road paving, and wrap it up and allow the houses to move on in. You see the deliver tiny homes, that's the last thing. But that's just an initial crack at how you could sequence this. You know, if your site plan isn't conducive to doing it this way, do it a different way. This is something that would work. It's one way. There's no right or wrong answer when doing this. And I think that'll wrap up the presentation portion.
Awesome. Thanks, guys. I feel like that was a ton of really good in-depth info. Do you guys have any questions? I know that was a lot to take in. Comments? Nothing?
I guess we did an amazing job presenting.
So good.
I have a question for you guys. If you are interested in pursuing some kind of job in construction, what type of background is it? Engineering, architecture, construction management would you recommend? I guess obviously all could move into construction at some point, but is there one that's best to start with?
I would say that probably 90% of my peers went to school for construction management. And there's some really good programs if you're wanting to stay in Colorado for that. But really it's if you want to, you know, I mean, you can go into any discipline. Like I was civil. I know a lot of people that are mechanical engineers that wanted to be on the MEP side of the construction business, and Charles hit on it with that VDC stuff, but they actually love doing that type of work because they get to have what they think is their impact day to day of something that's getting built real time. So, but yeah, there's not really, it just depends on what kind of discipline you want to go into. There's so many aspects of construction, the MEP side, the civil side that, you know, that I went into, electrical and all that stuff. And so there's really no right or wrong answer, but I would say most of the time it's construction management.
Yeah, I absolutely concur with Daniel. I work with people who are civil engineers, who are construction management majors, civil engineers. Like really, any of the engineering programs, construction management, they're certainly not all equal, right? You do learn different things with each one, but any of them will get your foot in the door for sure. If you're kind of leaning one way, but maybe think you want to swing back the other, you know, go for one of them. You can always use your experience to maybe switch fields or kind of create a career path to get to where you may want to go, even starting out in a different field.
One more add on to that. I actually know somebody who just got into construction last year who was a principal for about 10 years. And when he moved to Colorado, he didn't want to have to go back through it. And so, but he jumped in the construction world and loves it. So it's really open to whatever you want to. If you're open to construction, it'll be open to you. But Tim, looks like Tim asked, what can designers, engineers, architects do ahead of construction to make your job easier? I would say my big thing that I've seen is just making sure that you're coordinating, not just within your company, but with everybody that's going to be on the job. I know there's like usually a general architect that kind of oversees everything, and they'll miss conflicts within their own drawings that won't get discovered until the construction phase. And so just more of that coordination. I really hit on the communication part, but that is so important in the early phases. That way it's caught before it's about to go up.
Yep. Thanks, that's good.
Nothing else, guys? Y'all are just ready to hop in and get to work? Figuring out how to build these? Okay. Well, we'll go ahead and break out then. Thank you so much, guys. I thought that was a great presentation. We'll go ahead and break out into our rooms and teams and just keep working on what you're working on. Last week, I think most of you got pretty far with laying out your site plans, which looked awesome. So continue working on those. And then if you want to get into any of the construction stuff that we talked about today, like if you want to look at budgets or scheduling or any of those things, I think we're required to do a budget this year. So that might be a good thing to start thinking about and talking about a little bit today, just to build off of our presentation. Because then next week, we're going to talk a little more about sort of the layout of the individual spaces, like the community center and the tiny homes. So maybe looking at finishing up what we worked on last week and then moving on to some of the construction related stuff for this week in our groups. It might be good if we can split up our construction guys into different, so you're not all together.
Yeah.
To help a little bit with that.
Yes, you're just gonna have to send me somewhere.
Still, oh man. All right, I'm gonna send you to room 3.
Okay.
Wait, how do
Mine
I
worked this time.
find? Man, I don't understand it. It's like every time. It's crazy.
Let's see, I'll go to room 4.
You know, neither of our gateway students are on today.